Hi everybody. Today is lesson 2 of module 2. We're going to use the number line to model the addition of integers. Students will be able to use a number line to add integers. So I'm realizing that we probably should have had the vocabulary card integer yesterday in lesson 1. Integers are positive whole numbers, they are negative whole numbers, and 0. The negative and positive fractions and decimals are technically not integers. They are part of the rational number system. Commutative property. We've learned this for a while. 6 plus 3 is 9. So is 3 plus 6. 2 times 4 is 8. So is 4 times 2. Commutative property, you can add or you can multiply in any order, and you'll get the same answer. Absolute value we talked about and used yesterday. We're going to continue to use it today. Modeling addition on the number line. Complete the steps to find the sum of -2 plus 3 by filling in the blanks. Model the equation using straight arrows. Curved or hopped arrows are perfectly fine. I'm going to split the screen because the number line, unfortunately, is on the next page. All right. So we're going to place the tail of the arrow on 0. We always start our movements from 0. We're going to draw the arrow 2 units to the left of 0. 2 units to the left because it is -2. 2 units to the left. I like to do hops so that I'm sure to count correctly. Always put your arrowhead on to show which direction you're moving. So draw the arrow 2 units to the left of 0 and stop at -2. The direction of the arrow is to the left since you are counting down, or because it's a negative number. You're going to start the next arrow at the end of the first arrow, or at -2. We're going to draw the second arrow 3 units to the right, since you are counting up from -2. So remember, the problem is -2 plus 3. The second addend is +3. So we're drawing 3 to the right, starting at where you stopped. 1, 2, 3. Put your arrowhead on. Where did we stop? We stopped at 1. We're going to circle the number at which the second arrow ends to indicate the ending value. We stopped at 1. Sounds a little familiar to yesterday. We're going to repeat the process from parts A through F for the expression 3 plus -2. Wait a minute. That sounds familiar. We just did -2 plus 3. Now we're going to do 3 plus -2. So we start the arrow at 0, and we go to the right 3 because that's our first addend. 1, 2, 3. Arrowhead to show what direction. Then where we stopped is where we start. So I'm starting here, and I'm going to go to the left 2. 1, 2. Arrowhead to show what direction. And where did I land? I landed at 1, so I circle it. 3 plus -2 equals 1. What can you say about the sum of -2 plus 3 and 3 plus -2? Both examples we just did. Does the order matter when adding numbers? Why or why not? Well, we found out that they both stopped at 1, so they both have a sum of 1. Did the order matter? No, order does not. Order does not matter when adding because of the commutative. That's spelled out. Let's try that again. Commutative property. So how does absolute value determine the arrow length for the -2? Both of the problems we just did had a -2 in it. The absolute value, so I read this as the absolute value of -2. What is that? Absolute value is distance from 0, so absolute value of -2 is 2. So the arrow is 2 units, but the number is negative. Right? So we move the arrow to the left. I'm going to get rid of this split screen. So remember the problem, both had a -2, adding a +3 in it. How does the absolute value determine the arrow length for 3? The arrow moves 3 units to the right because it's positive. So let's use the number line that we have right here. How does the absolute value, this can go together, how does the absolute value help you represent -10 on a number line? I'm going to move, how many units? 10 units. In what direction am I going to move? I'm going to move to the left. Why? Because the number is negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And don't forget your arrowhead to show what way you're moving. So I would like you to pause the video and try both problems A and B. Don't just, even if you think you know the calculation answer, please represent it and model it on the number line. So -6 plus 4, I'm going to go to the left 6. 1, 2, 3, 4, 5, 6. Starting where I stopped, adding on +4. So I'm going to move to the right 4. 1, 2, 3, 4. Remember your arrowheads. I stopped the -2, so the answer is -2. 3 plus -8. I start at 0. I move to the right 3. 1, 2, 3. From there, I move left 8 because it is negative. 1, 2, 3, 4, 5, 6, 7, 8. Where did I land? At -5. 3 plus -8 is -5. Oh, this looks a little different. Straight lines or hops, it doesn't matter. Keep that in mind. A lot of people can do better counting with the hops. Some people can do the straight lines. I think we all know I can handle both, but I prefer the hops. Write an equation to express the sum. Well, remember, we always start at 0. So what is our first addend in this picture? The first addend starts at 0 and goes 5 units to the right. From there, we went 2 units to the left. So I'm adding -2. And from there, I don't care where that arrow stopped. I'm picking up a third arrow at that location and I'm adding on 3. Where did my last arrow stop? At 6. Equations need equal signs. So 5 plus -2 plus 3 equals 6. What 3 cards are represented in this model? I see a 5, I see a -2, and I see a 3. In what ways does this model differ from the ones we used in lesson 1? Well, now there's 3 addends. And in lesson 1, we were stopping at 0, weren't we? Now we're not. Didn't stop at 0. Can you make a connection between the sum of 6 and where the third arrow ends on the number line? It stopped at 6. So the sum, the answer to addition, is 6. Do you think the sum would change if we change the order in which we add the numbers? So up above, it was a 5 plus a negative 2 plus a 3. That's a different order, isn't it? Can the order change in addition? Yes, it can. Commutative property will still give us 6. Would the diagram change? Do you think it would look different? Would those arrows look different? Yes, they would. The arrows would be different. But what would be the same? But still land on 6 at the end. So exercise 3 says to play the integer game. We're going to do that in class tomorrow. So right now, make sure that you have all of your notes ready. Make sure you have your questions ready. Feel free to play the video again if you need to, and I'll see you in class.